Here are 4 SMC SF-16 pedestal fans. This is probably the most of these you'll ever see in one video in one place. These are 4 identical models from the late 90s. 3 of which I bought at the same time, so they likely came from the same household. Those are the 3 on the left, and the one on the right I found separately a couple of years earlier. I have cleaned and serviced this one and used it a fair bit. These 3 I have not cleaned and serviced yet. These are all in pretty much the same condition. One of these still has the protective film along the control panel. Most, 3 of them anyways, are yellowed only along the back edges of the control box, which is kind of unusual. I guess they all just happen to sit in front of a window, except for this one. This one's not really yellowed at all. This one also has a separate UL sticker, whereas the other ones do not. Actually, the sticker is completely different on these other ones, although it seems to contain much of the same information. That's E52594. 52594. And that's also 52594, so it's all the same UL number. And for whatever reason, this one cost $8, this one cost $8, and this one cost $5, and I don't recall what that one cost. So these 3 that I got more recently, although I have never cleaned and serviced them like I have the 4th one, these 3 do not seem to be running up to spec. They just seem very, very weak and slow. I don't think that this is how they're supposed to be. We're going to find out because we're going to compare it to this other one. But I'm suspecting it would have to be a capacitor problem, because while I haven't cleaned and serviced them, they don't appear to be very high hours or all that dirty to the point where it's going to start impacting performance. And they're really quite clean, especially for a 20-something-year-old product. So I've got them all plugged in. I don't have 4 meters, so we'll just have to get a overall rating of them all together. We're testing at 119.8 volts at 0.45 amps apiece. The whole thing in total should be a little under 2 amps. Put this back on the tripod, and here we go. We're going to start it on stationary, and we'll put them on low to begin. The power draw is 1.27 as they all get up to speed. .26 amps, 145 the watts, with a power factor of 0.96. Now that one on the end is running considerably faster, so I'm going to unplug these 3. This is a brand new power bar. The cords are real stiff in there. And that one by itself is pulling 0.32 amps. So now let's plug in one of these. And let's see what this one draws. 0.35. So it's actually drawing more. that one. Let's just try one more. Rule out any anomalies here. The other one is also 0.35 on the nose. So that's interesting. So my speculation was correct from when I first tested these, that they're running very slow. This one I would say is running twice or more faster than the other three. The power information is not supporting that, but we don't really know what the cause of the problem is right now, so the power information could be irrelevant. I can barely feel the other three. I can feel a strong stream from this one on the right. Huge difference in performance. Much less air. All three of them are like that. I don't know if the camera's frame rate's high enough to tell, but you can see it pretty clearly in person that the one on the end is running much faster. Okay, now we'll go up to the medium. Medium, it's the same thing. This one is much more powerful. The power draw in total is 1.38 amps, 162 the watts with a power factor of 0.97. Yeah, there's definitely something wrong with those other three. That's pretty powerful, and this is not. I can only imagine it's got to be drift capacitors. Alright, let's try the high. The power information is 1.61 amps, 190 watts. Power factor of 1. And at full speed, it's still the same. The one on the right is much stronger. I can feel that one blasting clear across the room. The other ones I can feel, but not much. This one's actually putting out an impressive amount of air. That's traveling far across the room. These three are all the same. Listen to the difference in the sound. It's a huge difference. It's like twice as fast than the other three. Way faster. They are pushing some good air though. Look at that moving around. Well, most of that is coming from the one on the left. You can see how the one on the right is barely moving. On the left it's whipping around. That one is moving so much more air. Hear the difference? This is how it's supposed to be. Now I'll move to the oscillation. Logo going every direction. The 2 or the medium. The 1 or the low. Or the off. Alright, I'll turn all the oscillations off now, and then we'll cut them all off at the same time. You know, it is possible that even though these are all TF-16 or SF-16s, that there's something different about them, because this one, if you turn the oscillator knob, the whole thing moves, whereas these, the knob just spins. So it's possible, oh no, maybe the knob is just loose. Okay, disregard that theory. Yep, there's a screw in there, probably just loose. Okay, just completely cancel out that theory, that's wrong. Okay, now I'll shut them off. And these have steel bearings, so they're going to coast for some time if they're in good shape, like the one on the right. So here we can see the difference between serviced bearings and non-serviced bearings. Alright, well that was neat to see all of these together, and that was a very interesting comparison that confirmed my suspicions that something is off about those three. So, those will definitely be one of the projects for this summer. I'm going to take a guess and say that it's a capacitor drift.